Hey everybody, and welcome back. We're going to continue on with properties of logarithms today. You'll see in red that our learning target is I can apply properties of logarithms to expand or condense expressions. Let's talk about what those two words mean before we go any further. That way we have our expectations clearly set. We don't know what the properties are, but we obviously know what a property is. It's going to be some kind of key information that tells us something about how to evaluate logarithms. Then the other keywords there are expand and condense. When we expand something or condense something, I'm kind of thinking about a slinky or maybe an accordion or something. When I expand it, I'm stretching it out. I'm making it lengthier. When I condense it, I'm compressing it, I am shrinking it, or I am minimizing it. I'm making it smaller or shorter. And so when we talk about using properties of logs to expand expressions, we're going to rewrite it in a longer, expansive way. Or if our directions say to condense them, then we're going to take what's given to us and compress it or shorten it somehow using those properties. Those three properties are sitting right here in front of you, and those are also included in that properties sheet that's posted in Wolfden for those of you enrolled in my Math 111 course. But we're adding 3 rules today, technically a 4th one, but we won't be using the 4th one, which is on the next slide, very much for this class, but I still wanted to introduce it to you. You will have some questions about that 4th rule, but these 3 are the ones that you are going to use extensively, especially in our last section in solving equations. The 3 properties that we're taking a look at today are the product rule, the quotient rule, and the power rule. Now remember, every time that we were together in class, the thing that I've nailed home to you over and over again was mathematicians are very intelligent. They're very complex in their thinking, but they're not very creative when it comes to the titles of their terms or the titles of their formulas or their theorems. Like whatever their formula or their theorem says, most likely is written in the title. So when we see something called the product rule, then our brain should immediately think that this rule involves the product of 2 things or multiplying 2 things. And you would be correct in thinking through that. The product rule is going to say if I've got 2 logs with the same base, I want to place emphasis on that. 2 logs with the same base, then I can combine them together. Okay? Or, if I have 1 log and it has multiple terms inside of it, then I can expand it. So take a look right here at this first statement. Log base b of r times s. I am taking the log base b of r times s, both of those things. And so if my direction said I want you to expand this logarithm, then I can expand log base b of r times s. I could rewrite that as 2 separate logarithms. I could rewrite that product of rs as log base b of r plus log base b of s. Notice that they still have the same base. That has to happen. If they don't have the same base, then this isn't going to work. But that's your product rule. Kind of taking you way back earlier in your math career of school and learning, when you first learned your order of operations and you first learned operations themselves, maybe you were taught that addition and multiplication generically allowed you to increase in value, whereas subtraction and division typically decreased in value. And so you learned that those pairs kind of went together. Same thing with multiplication and division. 2 squared is the same thing as 2 times itself over and over again, or 2 plus 2 is the same thing as 2 times 1, or 2 plus 2 plus 2 is the same thing as 2 times itself 3 times. They go together. So the product rule is going to link multiplication and addition together. Now keep in mind your learning target says I can expand or condense logarithms. So if I gave you this statement on the left, then I could ask you to expand it into the one on the right. However, maybe I start you out with the one on the right that says log base b of r plus log base b of s. Because those two separate logarithms have the same base and they are connected through addition, I can condense them into one log statement, which would be what's written on the left-hand side. Okay. So I included another example for you down here below the product rule, just so you have an idea of what it looks like. I have it written out for you just because I post your PDF notes, but I also am just going to walk through that with you. So say I give you log base 2 of 8 times x, or 8x is typically how we would write that. We always have to look at 8x and recognize that that is a product happening. Those are two terms being multiplied together, 8 times x. I can rewrite that. If my direction said expand this logarithm, I can rewrite that as log base 2 of 8 plus log base 2 of x. Notice they've got the same base. That has to work. That is a part of the product rule. You don't just make up a random base. You keep the one that's given to you, and you can expand it using addition. Now, your directions are always going to say, in this situation, it would say expand your logarithm, period, simplify when possible. So simplify meaning what we did last class. Looking at those two different logarithm pieces, is there one that you can simplify? And the answer would be yes. Let's walk through each one of those and make sure that we cover all of our bases, no pun intended. Log base 2 of 8. Now keep in mind, that's the same thing. Remember, around the world, 2 to what power equals 8? Okay. Think about it. 2 to what power equals 8? If you need to write it out, 2 to what power equals 8? And that would be 3. 2 to the third power is 8. So I can simplify log base 2 of 8 down to 3. This is why I told you last class you have to learn those properties. You've got to keep up with them. You cannot get behind, because every single thing that we learned last class you are going to learn to use today, and everything you learned last class and today's class you will 100% use in our next section of 5.4. If you do not learn these properties, you will be completely lost in 5.4, and I won't be able to help you. My only response will be, do you know your properties? And if you say yeah, then I'm going to say, well, then you should be able to do it, because the properties tell you exactly what you should be doing. Okay? So please, if you have not learned your properties from 5.2, you need to study them ASAP. And you need to learn the new properties for today's class as well. Continuing on to that second log piece, let's just make sure that we can't simplify it either. That would be same process, 2 to what power equals x? Well, we don't know what x is, so how do we know what to raise to 2? Okay. So this one we wouldn't be able to simplify. We would just leave it alone. Okay. And so this is that original logarithm fully expanded and simplified. Okay. Pause this video if you need to. Jot down some notes. Rewind it if you need to. Moving to our second property, or our second rule for today, is the quotient rule. Now, again, remember, mathematicians are not creative, okay? Not in the way of, let me come up with this super cute, catchy title. It's what it is, here's what it is, here's what I'm going to call it, plain and simple. It's difficult enough to do the content. I'm not going to try and confuse you on the title. So the quotient rule is literally going to be dealing with a quotient, and you should know what that means. You should know that a quotient is the division of two numbers, or two terms. And so the quotient rule for logarithms is going to involve taking the log of a division. Okay? Taking the log of a term divided by a term. Okay? So let's take a look at this example, and then we'll walk through that second one together. Okay. On the left-hand side, we have the log with a base of b. Now keep in mind, we're just using those letters as placeholders, those variables as placeholders. That could be anything. That could be log base 2 of 12 divided by 7. Okay? And it doesn't matter. We're still going to treat it the same way using the quotient rule. The quotient rule says if I'm taking the log of some base, okay, of the division of two terms, then I can rewrite it as a subtraction or a difference of two different logarithms. Remember up at the very top I said addition and multiplication are connected. Subtraction and division are also connected. And so I could rewrite log base b of r divided by s. I could rewrite that as the difference between two logs. Log base b of r minus log base b of s. Okay? And so that is what it would look like. I could give you the left-hand side and I could say condense. Or sorry, not condense. I got those backwards. I could give you the left-hand side and I could say expand, meaning rewrite this with multiple terms. Rewrite this using the quotient rule. Or I could give you the right-hand side and the directions could say condense this down, meaning take it from two terms down to one term if possible. Okay? And keep in mind we're going to simplify the whole way through on all of these as well. Okay? And so here's the numerical example that I gave you to represent the quotient rule. Say I give you log base 3 of 1/3. Okay? Well, when I see that, initially my brain sees 1/3 and I think, ooh, fraction. Okay, that's yucky. But we have to remember that fractions come from division. Fractions are not separate entities from our four operations. 1/3 is the same thing as 1 divided by 3. And a lot of times we forget that because that is so basic math, such a basic math concept from elementary school, early middle school, and when we get to high school we start dealing with thirds and fifths and multiplying by reciprocals. We forget those basic math concepts. So we're tapping in way back to the past into one of those archive files here. 1/3 is the same thing as 1 divided by 3. Okay? The directions would say I want you to expand this logarithm. Well, what I notice is that I am taking the log of a division, and in my mind I'm thinking, okay, what rule do I know that lets me split up division? The quotient rule, because a quotient is when I divide two numbers or two terms. Okay? So I can rewrite and expand this logarithm into two terms as log base 3 of the top number, the numerator. We got to make sure that we get that right. Okay? I don't know why people get that confused, because when we read a fraction, we always read the numerator first over the denominator. So when I'm expanding this logarithm, I'm going to write the numerator first. I'm going to say log base 3 of the numerator 1 minus log base 3 of the of the denominator 3. Numerator first minus the denominator part second. Okay? Now your directions are going to say simplify when possible. So let's make sure that we can't simplify each of these pieces. Okay? So think about it. From last class we learned you can call it whatever you want. You can call it the official property term, but I call it the around the world method, where I start with the base and I go 3 to what power is going to equal 1. 3 to what power is going to equal 1. Okay? And that's a little tricky. That's one of those things that we tend to forget because we don't use it every day in math class. But if I want to raise a number to some power and get 1, that will always be 0. 3 to the 0 power is 1. So log base 3 of 1 is going to be 0. And that's going to work anytime. Log base 500 of 1 is going to be 0. Okay? Minus All right, log base 3 of 3. 3 to what power gives me 3? 3 to what power gives me 3? Easy, that's 1. Okay, and then 0 minus 1 is negative 1. There's your final answer, even though the directions said to fully expand your logarithm. Okay, this is fully expanded, but you also simplified it along the way. Okay. Now, some of you might have been able to look at log base 3 of 1/3 and immediately tell me that that's negative 1. You could have done that. I want to remind you of all those other properties that we learned last class. Okay. Log base 3 of 1/3, remember that 1/3 could be written as 3 to the negative 1. Okay, so that's one of the things that we learned, or that we reviewed last class. That's not a property, that's just something we reviewed. We should know it, and if not, you're studying up on that. Okay. The property that we did learn was that if we are taking the log of a number and that number is also its base, then I can drop the base and the log part, and then what's left is my answer, which is also negative 1. Last class's video, I talked to you about how there are going to be several different ways to get to an answer. This is no exception here. You could have done it like that and gotten an answer. However, because the directions said to expand, this is what I would be looking for in your shown work, is that expansion. If the directions said evaluate, either one of these would have worked. But since the directions said expand and simplify, this is the shown work that I'm going to be looking for. What's over there in the green and red and blue. The last rule that we're going to take a look at is the power rule. And again, common sense, the power rule, a power is an exponent. And so the power rule is going to be dealing with me taking the log of something that also involves an exponent or a power. And so you'll see that in this variable example up here. I've got log base b of r to the c power. Now if your direction said expand this, the power rule simply says if I'm taking the log of a term raised to a power, then I can take the power and pull it in front of the logarithm as a constant. Okay. So I could rewrite log base b of r to the c power as c times log base b of r. That would be how I could rewrite it, expanding it. Maybe your directions say condense, and I give you this. Okay? And this is kind of the harder one to see, in my personal opinion. Maybe it's not for you, but for me it is. Anytime that there's a number sitting in front of a log, I can use the power rule and jerk it back up to be a power, like what's written on the left. That is typically not my go-to choice, but I am telling you that it is an option for you, especially if I give you something like this and I tell you to condense it. That would be exactly what I would be looking for. Okay. So last example of these rules before we move on. Say I give you log base 2 of 4 to the 5th power, and I tell you to expand that and simplify when possible. Okay. Well, the first thing that I notice is that, okay, so start walking through your list here. Am I taking the log of a product of two terms? No. Am I taking the quotient, or am I taking the log of a quotient? Meaning, am I saying log base b of a term divided by a term? No, I'm not. So those two are out. And that's exactly your thought process throughout this whole chapter. All right, what about this property? Will it work? No. What about this property? Check or X? X. And you keep running through your list until you figure out which property is good for you to use. Okay. Then I get to my list, so I've X'd out option 1 and option 2. Now I'm sitting here thinking, I'm taking the log of a term raised to a power. I can use the power rule. Okay. I can take that power of 5 and I can pull it to the front. And I can expand this logarithm, or I can rewrite it as 5 times log base 2 of 4. Okay. Then I need to make sure that to simplify if possible. Okay, so I've got 5 times this logarithm. The 5 is now acting as a coefficient or as a constant multiplied to this. So I'm going to hold on to the 5, but then I want to see if I can simplify that logarithm. 2 to what power equals 4? 2 to what power equals 4? Okay, and that would be 2. So log base 2 of 4 is just 2. And then finish it out. What is 5 times 2? 10. And that would be how you would use the power rule to fully expand this logarithm and simplify. The last property that we will take a look at before we just try some examples is something called the change of base formula. Okay? Now, because we are at the end of our semester, we cannot get into a lot of detail with this property, but for any that are maybe watching this outside of my class, we can go way more extensively using the change in base formula. My students are not allowed to use a calculator on this test, and so this is as far as we will take it, is the directions saying use change in base formula to expand the following logarithm, simplify your answer when possible. However, your directions could say use change in base formula to expand this logarithm round to the nearest thousandth, where you would use a calculator. Okay? It all is just dependent on how you may use it. You might use this to actually solve an equation. My students won't be using that because we just don't have the time. We've got 2 more class periods and then we are done. So we are just kind of grazing the surface on this, introducing it so that you have that foundation for your future math classes. So the change in base formula is exactly, again, what it sounds like. I'm dealing with a logarithm, and I want to rewrite that log with a different base. Okay, and so let's look at the variable part first. Okay, so up here, let's say I want to rewrite log base b of x. Okay, I can rewrite log base b of x as, you can just drop this part right here, as log of x divided by log of b. Now keep in mind, when there is not a base written for a logarithm, that's a common log, meaning we automatically know that its base is 10. Okay? So I can rewrite log base b of x as log x divided by log b. Again, numerator goes in the top, divided by the denominator part goes in the bottom. Okay? But remember, one of the properties that we learned was that log with the base e of x is the same thing as the natural log of x. So I could technically rewrite log base b of x as the natural log of x divided by the natural log of b. It'll give me the same answer. Okay, so very quickly, if we look at an example down here at the bottom, we've got log base 4 of 12. Okay. Using the change in base formula, I can rewrite that as log of 12 divided by log of 4. Okay. I could also use the natural log. I could say the natural log of 12 divided by the natural log of 4. And those would be the same answer, which means I would take either one of those answers. Okay. Now, if we tried to simplify that, it would be e to what power equals 4. Nobody knows how to simplify that without a calculator, so leave it alone. E to what power equals 12. We don't know how to simplify that without a calculator, so we'd leave it alone. This would be our complete answer because it is changed. The base is now 10, okay, for both of them, and we can't simplify it any further. Okay. On the other side over here, this would be e to what power equals 4. Nobody knows. This will be e to what power equals 12, and nobody knows. Okay. I think I might have done that backwards over here. My apologies. If I didn't, I'm sorry. we'll just take another sec. The base over here is 10, so 10 to what power equals 4? We don't know. 10 to what power equals 12? We don't know. My apologies. Either way, these will be our final answers because we've changed the base and we can't simplify it any further. Okay? And again, for my students, this is the extent of the question that I would ask you. I would say use the change in base formula to rewrite the logarithm, simplify when possible. And that would be your question. You wouldn't be typing it into your calculator or rounding, anything like that. This will be it. So now all that's left for us to do is to just practice these 3 or 4 properties. I will tell you that I'm going to kind of go through these quickly just because you've got to learn the properties. Once you learn these properties, you'll be able to do these quickly as well. But me going super slow and us not getting to a lot of examples because I'm going so slow is not going to be helpful. The best thing that you can do is have the properties either in your notes or printed off from that property sheet that I've shared with you. Have those sitting beside you, and as I'm working through these, then make a note of what each property that you used, and then you maybe come back and redo them again on your own time to make sure you know how to do these. And then jot down whichever ones were really confusing and that you have questions on, and we can go from there. Okay? So our first set that we're going to look at, the directions say fully expand the following expressions using your log properties. Simplify when possible. So for number 1, I have log base 2 of 3x. What do you see? What am I taking the logarithm of? Am I taking the log of a product between two numbers, a quotient between two numbers? Is there a term raised to a power? That's the question that you need to be thinking through each and every time before you make a decision. When you ask yourself those questions, you should be able to recognize 3x is the same thing as 3 times x. I'm going to be using the product rule here. The product rule. Okay? And so I can rewrite this as log base 2 of 3 plus log base 2 of x. And remember, we always want to check to see if we can simplify any of these. So 3 to what power equal, or sorry, 2 base 2 to what power equals 3? Nothing that I know of off the top of my head. And so we're going to leave it alone. Same thing with the second one, 2 to what power equals x? We don't know what x is, so how can we possibly answer this question? We can't simplify it any further. So that's our final answer. Okay. Remember to pause the video whenever you need to, because I'm just going to keep on going without pausing. Okay. The second one, I'm taking the log base 6 of 6 divided by x. Think about it. What am I taking the log of? Am I taking the log of a product, of a quotient, or of a term raised to a power? I am dealing with the logarithm of a quotient, of the division of two numbers. So I'm going to be using the quotient rule. Okay. So I can rewrite this as log base 6 of the numerator first, 6, minus log base 6 of the denominator, x. Make sure that you have simplified everything. 6 to what power equals 6? That would be a 1. Okay. And then minus log base 6 of x, because that can't be simplified any further. Final answer. Number 3 is log base 3 of x to the 5th. Okay. Again, walk through that list of questions. Am I taking the log of a product? Am I taking the logarithm of a quotient? Am I taking the logarithm of a term raised to a power? Okay. And x to the 5th power, literally, if you say it out loud, which is another thing that I tell you to do all the time, read it out loud and listen to what you're saying. X to the 5th power literally says the word power. We're going to be using the power rule here. So I can rewrite this by taking the power and pulling it to the front. 5 times the log base 3 of x. 3 to what power equals x? We don't know, so we can't simplify it. This is our final answer. Log base 4 of xy divided by 3. So again, I'm reading it out loud and I'm thinking, what's going on in this problem? Is there a product? Is there a quotient? Is there a power? And for this problem, we've actually got a couple things going on. We obviously have a quotient happening because there's a fraction. So we're going to use a quotient rule. Okay. But in the numerator, we've got xy, which is the same thing as x times y. We've also got a product rule happening here. Okay. My suggestion would be to deal with the quotient rule first, and so that's what I'm going to do. I'm going to say log base 4 of the numerator minus log base 4 of the denominator. Okay. Then I'm going to deal with the product rule here. So I'm going to expand log base 4 of xy. I'm going to expand that to be log base 4 of x plus log base 4 of y. All of that's together in the product rule, and I have to keep the minus log base 4 of 3. And we're checking to see if anything will simplify. Nothing in blue simplifies. In the red, 4 to the what power equals 3. Nothing that we know of off the top of our heads. And so that is our final answer for number 4. For number 5, I think you're automatically seeing these are getting a little more complicated the further we progress. We've got log base 2 of x squared y cubed divided by z. So maybe you should pause the video and write out some different rules that you see before I just tell you. I see the quotient rule, but I also see the power rule, and I see the power rule actually a couple times. Okay? And I see the product rule. Okay. And let's talk through that. So the quotient rule is the numerator divided by the denominator. Okay. I see x squared, which has a power, and I see y cubed, which has a power. Okay. But those two terms are connected through multiplication. So the tricky part here is deciding what we should do first. My suggestion would be, let's do the quotient rule first. Okay. Then the next part is kind of the tricky part to me, is which one do I do first? Do I pull the powers or do I do the product rule? Here's what you need to keep in mind. Does the squared power apply to everything in the numerator? No. Okay. So if you try to pull a 2 in front of that log, then it's going to mess the problem up because the 2 is not a power for x and for y. Same thing with the 3. The 3 is not a power for the variable x and the variable y. So my suggestion, which is what you should be doing, is do the product rule second and then the power rule third. Okay. So let's just walk through it, let you see it, because a lot of you are visual learners here. Let's go log base 2. We're going to do the quotient rule first. So log base 2 of the numerator minus log base 2 of the denominator. So we did the quotient rule, check that off or scratch it through. Now, again, let me talk you through how am I choosing what to do next. If I try to do the power rule right now, I would mess this up royally, because I would say, okay, let me pull the 2 out front. Well, if you pull the 2 out front, what you're saying is that 2 is a power of the variable x and the variable y. This is what it would look like. So if you tried to put that back, that would actually be log base 2 of x squared y to the 6th. That's not going to work. That is wrong. Okay, so we don't ever want to pull powers out front until they are completely isolated to their one term that they apply to. So we don't want to use the power rule to pull the 2 out. We don't want to use the power rule to pull the 3 out front. We want to separate those terms first. So let's do the product rule next. Let's do log, I'm going to put these in parentheses because the product rule is together, log base 2 of x squared plus log base 2 of y cubed. Don't forget about your red piece. You got to hold on to it. And now, do you see how the x squared is now standing alone? I can now pull the power of 2 to the front, and that power only applies to the x variable, which is what we want to do. Same thing with the log base 2 of y cubed. I can now pull the 3 power to the front of that logarithm, and it only applies to the variable y. That's exactly what we want. Okay, so let's finish out this problem and we'll look and see if we need to simplify anything. For the power rule, I'm going to pull the power of 2 out front. So 2 times log base 2 of x, perfect, plus pull this 3 power to the front of its logarithm, 3 log base 2 of y. Don't forget your back end piece in red. And that is our final answer. Our last one on this slide that we'll take a look at is number 6. We've got the log of parentheses 3xy squared, all of that raised to the 3rd power. So first question, what is the base of this logarithm? It's not written, so that means it is a common log with a base of 10. The next thing I want to ask you, just like we have with all the others, what is happening here? What do you see? Okay. Do you see products? Do you see quotients? Do you see powers? Okay. I'm seeing several products and I'm seeing several powers. We've got to decide which one we want to do first. Okay. In question 5, we introduce the concept of, does the power apply to all of the logarithm or just this specific term? I want to ask you that question again. In number 6, do we have a power that applies to everything in that logarithm? Log of 3xy squared, all of that cubed. Okay. All of 3xy squared is being raised to the 3rd power. And so the first thing we want to do for this problem is the power rule. We want to pull that power of 3 to the very front. We want to rewrite it as 3 log base 10 of 3xy squared. Okay. So now we're staring at this. Let's ask ourselves that question again. I see another power of 2. Does that exponent or that power of 2 apply to 3x and y? Or does it only apply to the variable y? For this exponent, the only thing being squared is the y. So we do not want to pull that 2 out front yet. We need to wait until it is isolated in its own logarithm before we pull the 2 out front. Okay. So what we want to do for our second step is the product rule. We want to start separating some of this stuff. Now, we have to be careful, okay? And we have to be careful because all of that 3xy squared had the power of 3. So when we expand those using the product rule, all of them have to maintain that 3. Each logarithm that we're about to write is going to have that coefficient of 3 at the very front. So when we expand this further, it's going to be 3 log base 10 of 3 plus, you got to hold on to it again, 3 log base 10 of x plus, keep the 3 again because it applies to every term in that logarithm, 3 log base 10 of y squared. Our final step before we try to simplify is look at that whole entire statement. Is there anything else that we can expand further? 3 log 3, it's good. There's no product, there's no quotient, no power. 3 log x, it's good. There's no power, there's no product, there's no quotient. 3 log of y squared, that has a power. We've got to expand this one more time, and we got to use the power rule. Power rule says bring that power out front, but there's already a 3 sitting there. So that means you need to multiply the 3 and the 2 together. That means you're going to have 2 times that 3 log and now y. Keep everything else. Okay. And if I clean that up a little bit, two times 3 times the log of y, that is the same thing as 6 times the log of y. Now check and see if you can reduce anything down or simplify anything. For this first term, remember that this is base 10. 10 to what power equals 3? We don't know, so you have to leave it alone. 10 to what power equals x? We don't know, leave it alone. 10 to what power equals y? We don't know, leave it alone. So what you are staring at is a fully expanded version of what you were given in number 6. This is our final answer. Okay. Now we'll go to the second half of our learning target. I want to fully condense the following expressions using log properties. Condense meaning take this long statement and smush it, make it shorter, make it smaller, and then simplify it if it is possible. Okay. So think again about your properties. We got the product rule, the quotient rule, and the power rule. But you got to think about it backwards this time. It's not going to be as obvious. Condensing is a little more difficult because we're not looking and finding multiplication or division or power. This time we're looking for addition, subtraction, and a coefficient that we can put back using those rules. Okay. So for number 1, I've got log base 3 of 7 minus log base 3 of x. What do I have? If you start describing what you're reading in number 1, you should be describing, I've got 2 logs with the same base that are being subtracted. Which rule involves subtracting 2 logarithms that have the same base? That would be the quotient rule. And the quotient rule says if I've got 2 logs of the same base being subtracted, then I can put it back together as a division statement, as a single logarithmic division statement. So I can rewrite this as log base 3 of, the first one is 7, so that goes first, divided by x. Final answer. Number 2 says the log of x minus 1 minus log of 6. Okay, we have to be very careful on this one. It is a simple problem, but only if you read it correctly. So the first thing, what is your base? It's not written. This is a common log, so your base is 10. Secondly, log of x minus 1. What am I taking the logarithm of? Am I taking the logarithm of x? Am I taking the logarithm of negative 1? Or am I taking the logarithm of all of that? Third option is correct here. I'm taking the log of all of this because look at it, it's in parentheses. Those parentheses are telling you take the log of all of me. Okay. Take the log base 10 of x minus 1. Then subtract that from log base 6. Okay. So now that we've covered that, think about your rules that you know so far. Which rule says I've got two logs with the same base that are being subtracted? This is the quotient rule again. Okay. So I'm going to take the log of my base, which is 10. You can either write it or you can not. Log base 10 of the first term, which is x minus 1, divided by the second term, which is 6. Number 3, we have log base 3 of x plus 5. Again, we've got those parentheses, so I'm taking the log of that binomial, okay, plus log base 3 of 4. What rule lets me take the logs, or two logs with the same base, and add them together? Which property or which rule says here's two logs that have the same base, take their sum? That is the product rule, which means I need to rewrite this. I need to condense it down into one statement that involves a log of a product rule or a multiplication of two terms. Okay. So we have to be careful here. This is going to be log base 3 of x plus 5 times the second term 4. Now, if you're like me, that looks weird. I don't like that at all. I always like to put any coefficients up front, and so I would have written that step, and then my next step would have been to rewrite it like this, just because I can't stand having a coefficient behind parentheses. I like to have it in the front so that I can distribute if necessary. And so this is a final answer. I can't simplify that. 3 to what power equals 4 times x plus 5? We don't know because that's a variable in there. If you don't know the variable, you can't give me the answer that equals a variable. Okay. You can either leave it like that, or you can go ahead and, just like I was saying, you can distribute. And you can say this is log base 3 of 4x plus 20. Either one of those answers will be correct for me, and you can't simplify that any further. 3 to what power equals 4x plus 20? I don't know, and you probably don't either. There's not really a way to figure that out. So either one of those answers would be acceptable. All right, this next one, number 4. I've got 1/2 times the log of x minus the log of 4. The base is not written, so automatically I know it's 10. Okay. I see that there is a subtraction of two logarithms happening, and those logs have the same base. So in my mind, I should be looking at those properties, and I should be wrestling with the quotient rule right now. However, one of these logarithms has a coefficient. Okay. And one of those properties that we learned, if we expand one of those properties, it pulls something to the front. Okay. This is an example of the power rule. Okay. 1/2 is a power of x. Okay. And the only reason I know that is because I know that the power rule says I can pull the power to the front of my logarithm. Okay. And so I've got to decide which one comes first. Okay. And so I just want to walk through that process with you so that you can see which one you should choose first. Okay. So let's say we did the quotient rule first because that's the first one that we saw. If we did the quotient rule, then we would say, all right, I've got to rewrite this as one single logarithm, that I'm taking the log of a division problem. So log base 10 of x over 4. Here's the problem. Where does the 1/2 go? Because the 1/2 cannot stay out front. Why can the 1/2 not stay out front? Because 1/2 is not applied to the 4. The 1/2 only applies to the x term. So if you start out with the quotient rule, you've immediately messed up because that 1/2 only applies to the x term. I get that that is confusing, but that's really just a trial and error process that you're going to have to work through and practice on. There's not any other way that I can teach you or explain that to you other than the 1/2 power only applies to x, so I have to take care of that first before I condense it any further. So the first thing that I want to do is take care of that power and make this log of x to the 1/2 and keep the log minus log 4. Now that I've done that, I can condense it even further using the quotient rule. I can condense it to be the log base 10 of x to the 1/2 divided by 4. Right? Check your directions. We have fully condensed it. There's not really anything else we can do as far as properties go to condense it. Have we simplified as much as possible? No, we haven't. Because what is x to the 1/2 power? X to the 1/2 power is the same thing as the square root of x. And then divide by 4. Last class, we really put a lot of emphasis on knowing when you have a negative exponent or a negative power, what does that look like? If you have a fractional power, what does that look like? Okay. So again, I told you you're going to have to remember that and review it if you didn't. This is why it's coming back. If you didn't do that, then you would lose a point here on my test because you haven't fully simplified it for me. Okay. Number 5 looks like there's a lot going on, and there is, but don't let that freak you out. Read it out loud and then talk about what you hear yourself saying. Log base 3 of 4 plus 2 log base 3 of x minus log base 3 of 5. Okay. So I'm seeing all of these logarithms have the same base. So that's good. That means I can condense them using my properties. I'm seeing an addition symbol and a subtraction symbol. Okay, that addition symbol is going to tell me the product rule, and the subtraction symbol between two logarithms is going to tell me the quotient rule. Which comes first is the problem and the issue. Okay, we also have some leading coefficients here. We'll look back at number 4. Number 4, we had to deal with the power rule first before we did any other condensing. And so before we go any further, that's what I want us to make sure that we do. On that middle term, the plus 2 log base 3 of x, let's use the power rule and pull that back. Okay. So we are looking at log base 3 of 4 plus log base 3 of x squared minus log base 3 of 5. Okay. So we took care of the power rule. Now we can kind of focus in on the other things. How do we know which one comes first? Do we do the product rule first or do we do the quotient rule first? You already know the answer to this, even if you don't know that you know the answer. Okay. Anybody remember this guy? Or please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, and subtraction. Which comes first? Products and multiplication or quotients and division? Okay. multiplication comes first. The m is first. And so, likewise, we want to do the product rule here first. Okay? So we first want to rewrite that front part as log base 3 of 4 times x squared. And keep the back. Now that we've taken care of the product rule, we need to fully condense. There's one more step that we have to take, and that is the quotient rule. So I need to condense one more time using the quotient rule. Log base 3, the first term goes first, 4x squared, divided by the second term is written second. Simplify when possible. Can anybody tell me what 3 to some power equals this? 3 to what power equals 4x squared divided by 5? I can't. I don't think you can tell me that either. Okay? So this would be our final answer. Okay. For number 6, log base 3 of 4 plus 2 log base 3 of x minus log base 2 of 5. Now, some of you may be getting deja vu just sitting there looking at it because it looks just like number 5, or so we think. Find the difference. The difference between number 5's problem and number 6's problem is that back logarithm. That back logarithm has a different base. When there is a different base, I cannot combine that with what's up front. Okay? That is not what our product rule, our quotient rule, or our power rule say. They have to have the same base. Because I'm dealing with base 3s and base 2s, those are separate entities. You can think of them as not like terms. Okay? Like the marker and squirt bottle analogy that I used in class. A marker plus a squirt bottle will never give you 2 markers. They're not the same material, so you can't add them together. Same thing here. A log base 3 is not the same thing as log base 2, so you cannot combine them. Okay? So this problem, even though it looks just like number 5, it is not. And that is a mistake that a lot of people will make on their tests if they're not careful. You have to slow down. You have to read each problem carefully. Okay? So what can I do on number 6? Okay? What are my options? Okay? What I do see is there's a log base 3 of 4 plus a 2 log base 3 of x. So those 2 logarithms have the same base. Okay? And from number 5, we already know what to do there. I've got a power, so I can pull that power back. Keep the back. And then again, from number 5, we know that this front part will combine using the product rule. So log base 3 of 4x squared, keep the back. Now we have come to a stopping place because I cannot use the quotient rule on these 2 logarithms. They do not have the same base. And if they don't have the same base, then I cannot combine them using any of my rules. So the last thing that I have to think about is, does anything simplify? 3 to what power equals 4x squared? Nope. 2 to what power equals 5? We don't really know that off the top of our head either, so leave it alone. This would be our final answer. I would encourage you to put a star by that one just because it is tricky, and I want you to know that it could happen on your test, so make sure that you study the difference between number 5 and number 6 because it's most likely going to show up. Last one on this slide, number 7. I've got log base 3 of 27 minus log base 2 of 64. Okay. Well, the good news is that I don't see any variables, so that's nice. Okay. Even though we're not solving equations yet, we'll do that next class. Okay. But there's no variables. What is the base of each of my logarithms? My first one has a base of 3. My second one has a base of 2. Since they have different bases, can I combine them using the quotient rule? No, I cannot do that. They don't have the same base. I cannot use a property to combine them. I don't see anything else that I can do. There's no power property or power rule happening here. There's not a product rule that I can apply. There's not a quotient rule situation I can apply. So the only thing that I can do is try to simplify it. And so let's see what we can do there with simplifying. Look at that first one. 3 to what power equals 27? Okay. That's something I can simplify. 3 to what power is 27? 3. 3 to the third power is 27. Okay. Minus, let's see if we can simplify this second one. I've got log base 2 of 64. 2 to what power equals 64? 2 to what power is 64? How can I come up with that? Okay. I can also simplify that to be 6. Okay. So what is 3 minus 6? Negative 3. There's your final answer, fully condensed. The very last thing, I know that we're getting down to the end of our time, but we're almost done. The very last thing is that change in base formula. And if you remember this property, it's really simple, it's really easy. Remember, the process or the purpose is whatever that base is, I want to rewrite it as log base 10 or the natural log. Okay. And then whatever we have, we're going to simplify it, but we're not going to put it in our calculator. So for number 1, I've got log base 3 of 12. Using the change in base formula would be either log base 10 of 12 divided by log base 10 of 3, or you could do the natural log of 12 divided by the natural log of 3. Either one of those answers is correct. Okay. Try to simplify it. Okay. If I'm over on the log one, 10 to what power is 12? Nope. 10 to what power is 3? Nope. Okay. So that's my final answer. Okay. If I can't simplify that one, chances are I probably can't simplify the other one, the other option. You don't have to have both answers. I'll take either one. But if you happen to do the natural log, e to what power is 12? Can't simplify that. E to what power is 3? Can't simplify that either. Okay, so that's our final answer. Moving on to that second one, log base 7 of 10. Okay, if I rewrite that using the change in base formula, that would be log base 10 of 10. Ooh, that sounds like it could probably simplify. And log base 10 of 7. Okay. 10 to what power is 10? 1. Divided by log base 7. Because 10 to what power is 7? I don't know what that is. Okay. Last one, I'm rewriting log base 5 of 1/2. Okay. So log, instead of base 5, I'm changing the base, so I'm going to change it to log base 10 of 1/2 divided by log base 10 of 5. 10 to what power is 1/2? I don't know. 10 to what power is 5? I don't know. That's my final answer. Okay. Those are all the examples that I have for you that I'm going to do with you. Okay. On the next slide, I have left you 6 examples to work through. In your email to me, your check-in email, I want you to use one of each of these to explain whether you understand a concept or nope, I don't get it. Okay, so I want to hear how you understand how to expand and how you understand how to condense, or I don't understand, I don't understand. Okay, I'm going to put the answers. Actually, no, I'm not. I'm going to let you send me the answers, or if you have questions about them, then you can send me your questions about those. I will remind you we've got one more section. It'll be 5.4, and it is a lot. It is a lot of content, so you need to come prepared knowing all of those properties. Not print out the sheet and have it sitting next to you. If you do not know the properties, you will be so lost next class, and you will have no clue what I'm doing. And I am going to blaze right on through it, because my purpose in next class is really just a practice. It's, all right, we know how to solve equations and we know these properties. Let's practice putting them together. So next class is not necessarily new content. It's how do I solve these new equations using all this information that I already have learned. So you have to know those properties. Learn them, learn them, learn them. Okay? And then we'll be approaching our test review and our test. Okay? Let me know if you have any questions. Don't forget to send me your check-in email, and I will talk to you soon. Okay, bye.